Hello, Chemistry versus Space Science. This is the first of two videos for lesson number 2. This one's going to have valence electrons and Lewis dot structures. A couple things we're going to be doing here is try to figure out the number of valence electrons in an atom or an ion, and then to be able to draw the appropriate Lewis dot structure or Lewis dot diagram for an element. So, refreshing our memories, we know that if an atom is neutral, there's an equal number of protons and electrons. So for instance, gold has 79 protons, so it has 79 electrons. And copper has 29 protons, so therefore it have 29 electrons, if that was a neutral atom. Going back to the last unit, we asked ourselves, well, what if they are not neutral? Well, first thing is the number of protons don't change. If you change the number of protons, you change the identity of the element. So when you have too many electrons, then you're going to have a negative charge. And if you have too few electrons, that's going to have a positive charge. See, we don't change the number of protons, we only change the number of electrons. So the equation we used earlier on to figure out the number of electrons in an atom was to say, or in an atom or an ion, is to take the number of electrons, and that's going to be equal to the number of protons minus whatever the charge is. So for instance, aluminum plus 3 would have 13 protons, so that's 13 minus the plus 3, so that's minus 3. That means aluminum plus 3 would have 10 electrons total. And sulfur, or the sulfide ion with a 2 minus charge, that would have a total of 18 electrons because sulfur has 16 protons and it has a negative 2 charge. So 16 minus a negative 2 is 18. So the sulfide, the S sulfur with a negative 2 charge, is going to have 18 electrons. So we also take a step back and talk about a little bit about the Bohr model. I know we did this in the first unit, talked about it very, very briefly, where Bohr thought or realized or surmised that the electrons in an atom are in quantized orbits or in layers or levels. And each one of those layers or levels, they sometimes get referred to as shells. But those shells can only hold a certain number of electrons. So the first shell can only hold 2. It's really, really small, really only have 2. If I look at all the other shells, now again, some of these have asterisks. The first shell has 2. The second shell has 8. The third shell has 8. But here's where it gets weird. The fourth shell, if you look at it on the periodic table according to the way it's aligned, it has 18 electrons. The fifth shell has 18, sixth shell has 32, and seventh shell has 32 also. Now those asterisks are there for a second because we're going to differentiate between valence electrons and inner shell electrons. So this is the Bohr model that we're used to seeing, where it has the protons and neutrons in the middle. And when the protons and neutrons are in the middle, we have a, sorry, almost sneezed. We have the electrons buzzing around on the outside. So this Bohr model atom has 3 protons, 4 neutrons, but then it's a neutral atom and it has those 3 electrons buzzing around the outside. So one thing we're going to focus on here, we talk about electrons being responsible for bonding. Here we're going to look at which ones are responsible for bonding amongst all of them. So the reality is the ones that are on the outside are the ones that are going to come in contact with another atom's electrons first. So those electrons in the outermost shell are the ones that are being involved in bonding, and they are called valence electrons. So whatever number of electrons are in the outermost shell of an atom, that's the number of valence electrons, and that's what's going to drive the bonding we're going to deal with starting in lesson 3. So for instance, aluminum has 3 valence electrons, chlorine has 7, sodium has 1 valence electron, so that's the valence electrons, the ones in the outermost shell. When we talked about the periodic table earlier, it's mentioned the fact that there's groups and that some of the groups have a helpful assistance. The group number gives us the number of valence electrons. It makes it really, really easy. So if you look at just the A groups, So for instance, group 1A has 1 valence electron, 2A has 2, 3A has 3. Notice, see this trend. 4A has 4, 5A has 5, 6A has 6, 7A has 7, 8A has 8, all the way up to 8A. Now, all the ones that are B's, the middle section of the periodic table, groups 3B and above, they all have 2 valence electrons. So 3B has 2, 4B has 2, 5B has 2, 6B has 2, 7B has 2, all the 8Bs have 2, 1B has 2, and 2B has 2 also. So everything in that middle, that transition elements, they all have 2 valence electrons. So we're going to use something that's called a Lewis dot diagram to help us show how bonding occurs between atoms. So we're going to use this concept of valence electrons, and then we're going to piggyback on that to write a symbol, a diagram, that can help us understand how those valence electrons may interact with other atoms. So let's start by learning how to draw a Lewis dot diagram. So the Lewis dot diagram of an element, first thing you need to do is find your element on the periodic table. Then we're going to use those group numbers to figure out the number of valence electrons. And then as part of the Lewis dot diagram, we're going to put a number of dots around the symbol that represents the number of valence electrons. So remind you again, the groups, figure out which group the element's in. That would tell you the number of valence electrons. And now we need to draw only the valence electrons on this symbol. So each column is called a group. Each element in the group has the same number of electrons in their outer orbital, known as the shells. And the shell electrons in the outer shell are called the valence electrons once again. And just to remind you, it's 1, 2, 3, 4, 5, 6, 7, 8, except for helium, which only has 2 because that's all it has. So let's take an element on the periodic table. Let's take the element carbon. If we're going to write the Lewis dot structure for carbon, we write the letter C in the middle, and then we figure out where carbon is on the periodic table, and then we figure out how many valence electrons it has. So carbon, when we find it on the periodic table, it's in column 4A, or group 4A. So therefore, it has 4 valence electrons. So starting on the right, you're going to draw 4 dots, electrons, around the carbon. So you'll start by putting 2 over here. So you're going to put 2. Let me see if I can put this, make this do my thing I want it to. Okay, so anyway, you'll put 2 there, and then you'll go around. So the first 2, you go back, the first 2 have to go on the right-hand side on top of one another. 1, 2. Then after that, you go around counterclockwise, and you put 1 on top, 1 on the side, and then if there was a 5th one, it would be 1 on the bottom. This is a Lewis dot diagram. It's a symbol, the letter C, with 4 dots around it. Okay, so what I'm going to do here is I'm going to ask you to use your notes and try to figure out the Lewis dot diagrams of the following elements: hydrogen, phosphorus, calcium, argon, chlorine, aluminum, and helium. So hit pause, take a few minutes to see if you can actually come up with the appropriate Lewis dot diagrams for all those, and then we hit play. I'll go back through them and we will check the answers. So let's see how you did. So the first one was hydrogen. Hydrogen, you would start with an H, and hydrogen has just 1 valence electron, so you get the dot on the right-hand side. That's it. That's the entire Lewis dot diagram for hydrogen, H with a dot. Let's try phosphorus. So phosphorus is a P. Phosphorus is in column 5A, so it needs 5 valence electrons. First two go here, and then 1, 2, and 3. That's the Lewis dot diagram for phosphorus. Calcium, that is in column 2A, therefore it has 2 valence electrons. So 1, 2, and we're done. Argon, well, argon is in column 8A. And argon's in column 8A, so it has 8 valence electrons. So first one's here, second one here, third, fourth, fifth, sixth, seventh, and eighth. Notice how the dots, these two are immediately next to one another. These two are immediately top and bottom, same with over here. And these are next to one another. You're not just randomly putting around the symbol. There's 2 on the right-hand side on top of one another. There's 2 on the top right next to one another. There's 2 on the left-hand side on top of each other, and 2 on the bottom right next to one another. So it's like the 4 sides of a square. Let's keep going. Chlorine. Chlorine is in column 7A. So column 7A means it has 7 valence electrons. We add the 7 dots. 1, 2, 3, 4, 5, 6, and 7. This is the Lewis dot diagram for chlorine. This seems to be getting easier. How about aluminum? Aluminum is in column 3A, so therefore it has 3 valence electrons. 1, 2, 3, and we're done. And finally, the tricky one, helium. Helium is in column 8A, but it also only has a total of 2 electrons. So with 2 electrons in the only shell that helium has, those 2 electrons are the valence electrons. So helium's kind of a weird situation. It's an 8A, but it only has 2. So boink, boink. And that's the end of the discussion on the valence electrons and the Lewis dot diagrams. Our next lesson is going to be all about the electron configurations and how they play a role. We're going to come back to total number of electrons, and we're going to try to find a way on the next video to make a connection between valence electrons and this new thing called the electron configuration. I will see you on the next video. Toodles.